What I'm going to show you today is the construction and validation of a happiness index using Google Trends. Now, maybe you already know my work and you've seen it before and my data. We use Twitter to estimate happiness. We got a relatively, I think, a good index measuring happiness. And at the moment, we had to think of other options, but I'll tell you more about that. So this is the other option. So just to give you the idea of what we will do is the research problem, aim, contribution, data, methodology, results, conclusions, and questions and answers. So what is our research problem? Our problem is surveys. Surveys are costly. It takes long before we get feedback on them. COVID speeded up things a bit. So what can we do? The solution is we use big data because it's easy accessible, much cheaper, and we can get it at almost real time, which to me is a major benefit, and to policymakers to almost know immediately what is the mood, what is the effect about whatever they did. Or there's very other scenarios, not just policymakers. So what is the contribution? Previously, there were real-time indices, mine, Twitter index, mine, GCO, the Gross National Happiness today, and then we also had the odometer. So those were running real-time. You can go on the website and you can see what's happening. That was the end of the story of Twitter. My fellow countrymen that was in the school next to me, Boys High, decided this is the end of Twitter. Elon Musk stopped Twitter. So we can't use Twitter any longer. But thanks, Elon Musk, you did us a big favor because we started experiencing with everything. So I will still write him a nice letter to thank him. So our main thing is to get a real-time index, once again, up and running on a website. You can go in and have a look at happiness. We're starting with happiness. And for those people that are not sure about happiness, the definition, I know all of you are well-being researchers. So we are speaking here positive effect, short-term positive effect, something like a question, how did you feel yesterday? Did you have interest in life yesterday? And don't confuse that with subjective well-being, because I get very aggressive if people tell me, I'm from South Africa, South Africa is not happy, is on the lowest rank, 128. Come on, guys, just look a little bit further in the table. You will see happiness. We are number 17. And there's not one European country above us. So, by the way, next time. Did I skip slides? Oh, no, I didn't. There we go. So the point is we want to index. We would like to get it to be able to do a cross-country analysis and then trends, so time series. So we would like to have a panel data. Let's see if we can. So the data sets we use are quite a few because we've got Google Trends that we extract from Google. So that's number one. And the rest is for validation purposes. So for validation, we've got the ONS data, the Office of National Statistics data. We started with the UK because it's very nice. Happiness is a high frequency type of emotion. So we need high frequency data. ONS got weekly data. It's just a limited time series, but that helped us a lot. Then we've got a Dutch. I didn't do that. Then we've got a Dutch data set, it's time use data from 2011 to 2021, thanks to Ruud Veenhoven that started collecting it, but I will also tell you more about that. Then we've got the G&H, which is our previous Twitter data. And then for robustness check, we will be using EARS. Now, EARS is that early AI-supported response with social listening. So it's something the World Health Organization started. A lovely data set, but they stopped it. I don't know why. And it's daily. But also based on big data. That's why they can make it daily in real time. So, other way around. I'm not going to say more about the data, otherwise I'm going to bore you and I'm going to be here forever. So the methodology is we start off with looking for words that can explain emotion. So the starting point is obviously PANAS. Most of you will know PANAS, positive effect, negative effect survey, various formats of that. And then except for that, we use different sentiment analysis. So in the sentiment analysis, you will find lexicons with certain emotions. So we added that to get this as many words as possible. I just quickly want to highlight something. We are trying to estimate emotion, positive effect. We've got Google Trends. We tried everything. We went through Facebook, everything Meta has to offer, Reddit. The problem is we ended up, the only one we can use is Google Trends. Google Trends is a search engine. So it's not a personal idea of a positive effect. If I'm happy, I'm not going to Google and say, hey, I'm happy. How do I, what? So when you search something on Google, it's either to find information or it's because you are negative. I would like to commit suicide. What is the best way to do it? So your searches will normally be negative. That is a problem, and we will work around that. Did I skip one again? All right, so that is just how we got the words. I will show you the results. Then on the methodology, I said put UK there, but we follow the same methodology with all the countries. We start, and it is, we say 65 words even in the paper, but I went and counted them, it's 72. So just a correction there. And then we did various things to narrow it down so that we can get only a few words. We first tested. We use happiness, the survey happiness index in the ONS, survey data. And from now on, I will call it true happiness. So anything, we correlated all those words with true happiness, anything significant, we kept. And the next thing is we kept about 42 words, and our timeline, number of observations, not that many. We've got 126. So that's the words we have weekly data for the ONS. So obviously, you know that if you've got 42 different, I wanted to say features because that's machine learning, but independent variables, with a dependent variable, you will get an overfit. And with these types of words, obviously multicollinearity. So we have to have another solution. We move to, did I skip again? Or I just shout if I skip. So then we used XGBoost, a machine learning, to show us which words are most important. From there, we developed the equation because we need an equation to estimate happiness. And remember, the whole time we're validating against true happiness, which is the ONS happiness. And to weight it, you need something. So if any of you build indices, you will know you can have equal weighting, you can have some type of subjective weighting. You can have what, there are so many, but we decided to use coefficients on a regression. Once again, you're running in the same problem, you're getting overfit, multicollinearity, solutions running in machine learning. I'm back. Okay, so let's get to the result. Now, these are the words we initially started off. I actually giggle. I find it very funny. Just have a look at the words. This is the UK. Look at the type of words. Sad, stressed, nervous, sick, hope, positive. Active, headache, well-being, positive. But anyway, you get my drift. Most of them are negative. And we all know, negative effect and positive effect is not inverse. So, but when you do searches, you get negative words. People search when they are negative, almost like the media, they publish negative. So what we had to do is we actually had to run a regression to see if they are really significant in explaining happiness. And we did. That is what we've got there. All right, I'm telling you to look at those words because I will give you some other words. And then I skipped again. So did I give you? No, I'm going forward. Okay. I'm blonde. So you've got the words. The next thing is, now we started with the regressions. So I'm skipping the XGBoost. If anybody wants to know how a XGBoost works, what is your algorithm, please come and chat to me. I don't want to bore you. So we now use ElasticNet. ElasticNet is a type of regression in machine learning. It's wonderful if you've got a small sample and you've got multicollinearity and you worried about over specification of a model, because it's got various ways to penalize these equations. What it actually does, I'm not going to explain a rich function and a lasso to you, but what it does, it use both of them and it shrink the coefficients. So if you use ElasticNet, you can actually estimate a regression with multicollinearity with too many independent variables, breaking all the rules. Fun. Okay, so this is what we found. So after we ran the ElasticNet, that is our predicted happiness against true happiness. And you can see the fit is quite good, especially if you think happiness is the emotion on ONS. We're working with search data. If you actually plot the equation, now we've extracted the equation with the coefficients, we've got an intercept. And if we plot it against true happiness data, that is our fit. So if you look at your root mean square error, we get a fit of 0.05. That doesn't tell you anything because you need to know what's the scale of the data, but I can tell you that's a good fit. Okay, so robustness, how did we check the robustness? How much time? Okay. So how did we check the robustness? We correlated it with a few other variables, which is as validated, accepted, trusted, and also we checked for time invariance. So we had quarterly data on the ONS going back for quite so many years, and we found a correlation significance 0.7. That might be a little bit low for you, but happiness changes over time. So if you start in 2011, you will find those words probably will change. The lingo change as you go along. Okay, so this is annoying. Sorry, guys. ES data. ES data is documents that they counted. So they've got a document number 12, which measures mental health, which is not happiness, but we get a relationship that we want, a negative 0.31. And then document 33 measures loneliness, and we also get a significant correlation there. And then we used exactly the same equation, same coefficient, same intercept, same words translated to Dutch. And if you look at that, it makes it a little bit harder. And at the end of the day, in the conclusion, I will tell you. So we've got the time use survey. There's a few problems with the time use survey. We don't have enough individuals because we had to obviously collapse the data to daily data. And later on here in 2021, very few observations. So we would like to test it with something else. And then, well, the first one was 2011. So, and the next one is still the time use data for happiness, but it's on a later time scale. We tested these things so many times. I had so much fun. This is, I really do enjoy it. I can't sleep. I get up and I go and do this because it's fun. But anyway, so I tested so many of these. If you actually look at the fit, and this is over the last time periods, you can see it's up to 2022 time use data with our equation, with coefficient, with the intercept. It's not a good fit. So what does that tell us? We will probably have to do this for every country that we have, because countries all have certain characteristics. They've got certain words. You can't just translate English to Dutch or to German, because they will have different emotion words. So any of you that's a language expert, if you want to volunteer to give me the emotion words used in your country, I'll be very, very glad to have them. Okay, 5 minutes. So, did I skip something there? No. So the last thing we did is South Africa had elections, and we tried to get this up and running before elections to measure to see what happened to elections. We don't have daily data in South Africa to validate against, so we validated against Twitter data. And this is what we got. This is using our elastic net. We once again found a good fit, 0.04. We wanted 0.01. The smaller you get it, the better the fit. But that's what we got. So there's our predicted against true happiness. And once again, just showing you the equation. Remember now we've got a different equation, different coefficients, different intercept to get the fit, to see if this is country specific. Yes, it is. Because here we can use words like lekker and Ubuntu and the type of words we use in South Africa. And then my end of the day is, what are we trying to do with data? We want to predict a population. How do a population, like an ensemble population, does the data reflect what really happens? Okay, so this is my equation, and let's quickly have a look and see if it actually shows what happens on the ground. You probably won't be able to see that, but that's Christmas. That is the 1st of January. This is Valentine's Day, and here's the election. So real-time elections. We had elections on 29 May, and we are now, this was up to yesterday morning's data, showing you initially a lot of uncertainty. People are very, very worried because the normally ruling party didn't get the majority votes. So there are a lot of changes, jumping around, coalitions, but it's starting to look better as we can see that the coalitions are settling and it's within the what do you call it? The medium parties, not the right wing or the left wing. So people are getting more confident. And then this was just for interest to look at the words that overlap, the UK and South Africa. There's a few of them. What I found interesting is that South Africa's got many more happy words than the UK, which tells me I'm worried about the UK. I think they are very stressed. And conclusions, you've got the conclusions. So in other words, we showed, validated, we can use Google Trends. It looks good. We will continue working on this for different countries. And there's my last question and answer. You know that eSquals is sponsoring some of this static. So I thought I can use this as a marketing tool. We've got a conference in October in South Africa. And it will be wonderful to have all of you there. The abstract deadline has already passed, but just send it to me. I'm your friend. If you can send it to me within the next week, let's say Sunday next week, we'll slip you in. Don't tell anybody. It's just because you are experts. Then it is time for questions and answers. 1.5 minutes. Okay, another marketing. Just advertising a bit. And this is so new. I only heard that I've been praying for this. This is my dream. I want a peer research center. I only want to do research. I got the okay, go ahead from my university. The new center will be called C.Wise. All right, I only thought of that name this morning, and I actually think it's quite a nice name. And the name is for well-being. And then obviously it's going to be a wellbeing center, AI and social sciences. And it's really just starting. As I said, I got the okay on Saturday, but we're looking for as many collaborations as we can find. You see the type of work that we will be doing. It will all be about social sciences, connecting it with AI, which is a big gap in the market. So there's my marketing for the day, and we're over to questions.
And Talita, have you had any initial response yet? I know that GNH was accepted and published by Statistics New Zealand. Have you taken this measure to them or any other groups? And what has your response been? Thanks.
This is fresh off the press. You are the first guys to know about this. So no, we haven't. And the first place where we will introduce it is static. I'm just asking, actually. Okay, any other questions? Oh, you said I must take them a few. All right, let's write down.
Yeah, thanks a lot for the presentation, really interesting. So I agree, so it's a pretty good idea because machine learning techniques fits well that kind of predictive tasks. The problem that, so it's a question that I ask you to see if you worried a little bit about that. The thing is that the principle is to continuously update the models, by extension the parameterization and by extension the weights. So this is how it takes all this power from. So what I wonder is at the end of the day, since you compare...
Okay. Can you speak slower, please?
Sorry. So I'm going to try to say it in a more slow way, So what you do is by using machine learning techniques, you use the cross-validation paradigm. At the end of the day, this is what you do. The thing is that it's useful also to update the models. So you get new data in the models, you change, you reparameterize the whole stuff, it reparameterizes itself. So at the end of the day, this is how you get the weights, okay? So you get the weights and you want to update the models, they will produce other weights. But at the end of the day, the weights, they determine the type of linear combination that you use to get your indicator. So what I'm a little bit afraid of is that you will have high frequency data, which is interesting, using big data sources. But are you really going to compare the same through time? Because basically you are going to, in that kind of production of indicator, you are going to reparameterize all the time the model. And so the weights.
We thought about that. We will address it because it changes. So we will have to reweight, which means we have to reweight, backdate it. So thank you for the comment, but yes, we will have to do, it will be reweighted. The words will change. So how we can do cross-country comparison, and so time series is easy. You just backdate your weights. Is it easy? We will have to think about it. As I say, it's new, brand new. Any ideas will be appreciated. Any gaps you see in this, because this is the future, I can tell you. If you're one of the youngsters around us, you will see that big data will take over survey data.
Yeah, I have no mic anymore. Sorry, I'm going to shout. So the question is, at the end of the day, what are you going to rerun, to reproduce the whole series every time you want to analyze it? Because if you don't do so, what you will end up with is at some point in time, you will have a given parameterization, so a certain type of weights that is going to determine the content of your indicator. But later in time, you will have other weights. And you will have actually some kind of a different concept. But is it something that worries you, or you think that at the end of the day, you will end up with something rather consistent through time?
Obviously, the ideal is to make it consistent. Next, we know we can't because things change. Next, what is the purpose of this index? Real-time information. So what we want to supply is real-time information. We're not writing econometric papers. We're trying to get policymakers to know what's happening. So yes, we will have to change the weights. We will have to change the words. If I want to publish a paper, I must consider all of that. But at the moment, my aim is to show a policymaker exactly what's happening in his country. And if he does something, South Africa, it's strikes, we would like to predict that. So we will use this index not only just to reflect what happened yesterday, but we will use nowcasting and forecasting, as my dear friend said, we really need. So we will add that in. Yes.
Thanks. I was just...
But I'm always available. Any ideas Tommy.
go ahead. Mine's really fast.
I just wondered if the prediction varies by age and whether or not you see a poorer prediction for older populations.
This is a very easy question to answer. If you do a Google search, as soon as Google tell us who did the search, we can do that. But Google doesn't actually want to share detail, although they know everything about you. They don't want to share it.